11:47 p.m., September 18, 1942, Boeing Plant 2, Seattle. Rose Kowalski crouched inside the B-17 wing root cavity, aluminum walls pressing close on three sides. Wing Assembly Station 7. Night shift. Fluorescent lights humming overhead, casting harsh shadows through the skeletal airframe. Her rivet gun weighed 12 pounds. 47 holes stared back at her from the wing structure, 47 rivets between proving she was right and losing her job. Plant manager Howard Mitchell stood on the catwalk above, watching, silent. Arms crossed. His career riding on what happened in the next 2 hours. The air smelled like aluminum shavings and hydraulic fluid. Someone's coffee thermos sat on a workbench 20 feet away, steam rising in the cool night air. The smell reminded Rose she hadn't slept in 18 hours. Outside the wing cavity, Helen Martinez positioned her bucking bar. 6 months experience. Good worker. Trusted Rose completely. Maybe shouldn't have. Frank Chen stood ready, with his inspection mirror and gauge. 15 years at Boeing, his inspector's license on the line if this went wrong. He'd lose everything. So would Helen. So would Rose. The stakes were simple and brutal. If this wing failed stress testing at dawn, Rose got fired. The bottleneck continued. American bomber production stayed stuck at 140 aircraft per month, while pilots died waiting for replacements over Germany. If it passed, everything changed. Rose pressed the rivet gun against the first hole. Her hands were steady. No shake, no hesitation. Time to prove that 8 years in Detroit and 2,000 wing installations were worth more than engineering specifications. Rewind to June 1942. Boeing's Seattle plant was losing the war. The numbers were nightmare fuel. Boeing produced 140 B-17 flying fortresses per month. The Army Air Forces needed 350. Simple math. Brutal consequences. At current production rates, America would run out of bombers before 1944. The 8th Air Force was bleeding over, Germany. 50 bombers lost per mission by 1943, intelligence projected. Crews flying obsolete B-24 seconds because there weren't enough B-17 seconds. Young pilots waiting months for aircraft while German fighters owned the sky. Commander telegrams arrived weekly at Boeing corporate. We need more aircraft or we're done. Not dramatic. Just factual. Desperate. The bottleneck wasn't worker skill. Wasn't factory capacity. The bottleneck was wing root assembly. That specific joint where wing met fuselage. 47 critical structural rivets. Each one required a 3-person team working in confined space with zero tolerance for error. The process took 24 hours per wing. Sequential installation. Install rivet 1, verify it, move to rivet 2. Safe. Methodical. Impossibly slow. Why it mattered? One bad rivet meant structural failure at 25,000 feet. Meant the wing tearing off during combat maneuvers. Meant 10 dead airmen screaming through 20,000 feet of empty sky. Production math was simple. 24 hours per wing times limited assembly stations equaled 140 aircraft per month maximum. No way around it, no solution. Engineers had tried everything. Larger rivet guns failed, pneumatic assist systems failed, resequencing the installation order failed. Nothing worked. Plant manager Mitchell told workers the truth during a July meeting. We're losing the war in Seattle, not over Berlin. Detroit, 1934. Rose Kowalski was 20 years old when Chrysler hired her for their assembly line. Third-generation Polish steelworker family. Her father worked the River Rouge plant for Ford. Her grandfather had worked steel mills in Pennsylvania before that. Metal was in her blood. 8 years at Chrysler, spot welding, assembly work, quality control. She was the fastest welder on the line by 1936. Trained over 40 workers, her hands bore scars from hot metal and sharp edges. She could identify steel grade by touch, could tell you if a weld would hold just by running her fingers across it. December 1940, Boeing opened their Seattle plant, recruiting nationwide. Rose saw the notice, took a Greyhound bus west, 2,400 miles, arrived in Seattle with $47 and one suitcase. Riveting training program, 6 weeks standard. Rose finished in 4. Her skill wasn't just speed, it was pattern recognition, understanding how loads traveled through metal structures, seeing stress paths that others missed. By September 1942, Rose had installed over 2,000 wing routes, knew every rivet point by memory, could work in darkness if needed, preferred night shift, quieter, fewer distractions, better focus. Her team: Helen Martinez on the bucking bar, 6 months experience but solid instincts. Frank Chen as inspector, 15 years at Boeing, methodical and fair. Both trusted Rose's judgment completely. What made Rose different wasn't talent. It was understanding. She didn't just follow procedures. She understood why they existed. And more, importantly, she understood when they were wrong. August 1942. Wing Assembly Station 7. Rose working her standard shift, installing rivets in the approved sequence. But she was watching something the engineers never saw. The wing flexed during installation. First 15 rivets went in slow. Constant adjustment required. The structure moved under the rivet gun. Alignment shifted. Every rivet fought against unstable metal. After rivet 20, something changed. The wing stabilized, became more rigid. Installation accelerated. Less adjustment needed. Rose saw the pattern. Not all rivets were equal. 6 positions were primary load-bearing. Rivets 1, 7, 13, 22, 31, and 44. These aligned with the main spar attachment points. These carried the structural loads during flight. The other 41 rivets prevented buckling, distributed stress, but didn't carry primary loads. Current method treated all 47 rivets equally. Sequential installation. But Rose understood something from automotive work. You torque engine head bolts in a specific pattern, not sequentially. Star pattern. Establishes even clamping force before final torque. Same principle should apply to wing structure. Install the 6 primary rivets first, create the structural skeleton, then fill in the secondary 41 while the wing was already stable. She mentioned it to her shift supervisor in July. He said engineers designed it this way for a reason. She mentioned it to Frank Chen. He said he couldn't verify what wasn't in specifications. She mentioned it to plant manager Mitchell in August. He said right field recertification would take 6 months minimum. But Rose calculated the impact. If her method worked, installation time dropped from 24 hours to maybe 2. Boeing could hit 350 bombers per month, could save the strategic bombing campaign. Decision time: break the rules, or watch pilots die waiting for aircraft. September 16th, 1942, 3:15 p.m. Plant, Manager's Office, Boeing Plant 2. Rose requested the meeting 3 days earlier. Mitchell's secretary tried to schedule it for October. Rose said it couldn't wait. The secretary asked what it was about. Rose said production bottleneck. The secretary scheduled it immediately. Howard Mitchell was 52 years old. Boeing engineer since 1928. 14 years watching aircraft evolve from wood and fabric to all-metal stressed skin. He'd survived the Depression, survived corporate reorganizations, survived design failures that killed test pilots. Now he was surviving the pressure of war production that demanded the impossible. He chain-smoked Lucky Strikes, ashtray on his desk overflowing, 3 empty coffee cups, dark circles under his eyes. The man hadn't slept properly in months. Rose entered wearing work coveralls, grease under her fingernails. She carried a folder with hand-drawn diagrams, stress calculations done in pencil, timing estimates on graph paper. Mitchell didn't offer her a seat. She sat anyway. "I can cut wing assembly from 24 hours to 2, Rose said. Mitchell stubbed out his cigarette. "Impossible." Rose opened her folder. spread the diagrams across his desk, explained the 6-rivet skeleton concept, primary load-bearing positions installed first, secondary rivets filled in afterward. Wing achieves structural integrity after 6 rivets instead of 47. Mitchell studied the diagrams. You're not an engineer. Engineers designed the rivets, Rose said. I install them 2,000 times. I see what they don't. Mitchell lit another cigarette. If one wing fails, 10 men die. If we don't fix the bottleneck, thousands die waiting for aircraft. That landed. Mitchell knew the casualty projections. Knew that bomber crews were flying missions in obsolete aircraft because there weren't enough B-17 seconds. Knew that every day the bottleneck continued, the strategic bombing campaign weakened. Right field certification takes 6 months, Mitchell said. Give me one wing, one night, I'll prove it works. Long silence. Mitchell smoked, stared at the diagrams. Calculated career risk. If Rose was wrong, Boeing would be liable. If she was right and he'd blocked it, he'd be responsible for the delay. One wing, Mitchell finally said. Friday night shift. If it fails stress testing, you're dismissed. Deal. If it passes, I take it to Boeing corporate Monday morning. Rose nodded. Only your regular team. Martinez and Chen. No extra help. Understood. Mitchell stubbed out his cigarette, lit another immediately. Why are you doing this? Because I know it works, Rose said. And we're losing. September 17th. Rose told Helen and Frank about the plan during lunch break. Helen's reaction, nervous but trusting. If you say it works, I believe you. Frank's reaction, concerned. Professional. If this wing fails and I signed off, I lose my certification. Then don't sign off, Rose said. I'll take full responsibility. That's not how it works. We all sign the paperwork. All our names on the inspection report. Helen asked the critical question. What's the actual risk? Structurally? Rose explained. 6 primary rivets create the load path. If those are perfect, the wing cannot fail. Secondary rivets distribute stress, prevent buckling, but don't carry primary loads. Frank wasn't convinced. And if you're wrong about which rivets are primary, then we're all out of jobs and 10 pilots eventually die when that wing fails in combat. Grim silence. They all understood the stakes. Helen spoke first. I'm in. Frank took longer. 15 years at Boeing. Never violated specifications. Never cut corners. But he'd also watched the production numbers. Watched telegrams arrive from 8th Air Force commanders begging for more aircraft. Finally, against my better judgment, I'm in. Word spread through the night shift by evening. Riveters talked. Reactions were mixed. Some supportive. About time someone challenged engineering. Some opposed. You're risking lives for your ego. Some jealous. Why does she get to break rules? Shift supervisor Jim Harding pulled Rose aside after dinner break. Former Navy mechanic, practical man, respected by workers. You know Mitchell's career is riding on this too, Harding said. I know. And if you're wrong, it's not just you getting fired. I'm not wrong. How do you know? Rose looked at him directly. Because I've installed 2,000 of these wings. I know how they move, how they settle, where the stress goes. The engineers calculated it on paper. I see it in metal. Harding studied her face, then nodded. Prove it. September 18th. Rose slept fitfully during the day, dreamed about rivet patterns, about wings failing at altitude, about aluminum tearing, woke at 6 p.m. with her heart pounding. She ate dinner, hands steady, arrived at the plant at 10 p.m., 2 hours before the attempt. The wing waited at Station 7. Freshly machined aluminum, pristine. 47 holes drilled and prepped. Each hole deburred, chamfered, ready for rivets. B-17 wing design, all metal stressed skin construction. 4 main spars running spanwise. Cantilever design, no external bracing. The wing root carried every flight load. Lift loads, bending moments, Torsional stress. Everything transmitted through those 47 rivets into the fuselage structure. Standard rivet, aluminum alloy 2117T, 4. 5/32 inch diameter. Round head. Installed with pneumatic gun delivering precisely calibrated hammer blows. Installation process was precise. Riveter inside the wing cavity cramped space, work by feel. Bucker outside with bucking bar solid steel tool pressed against the rivet tail. Riveter fires gun, rivet mushrooms between gun and bucking bar, creates permanent structural connection. Inspector verifies 3 things. Rivet, head formation, proper mushroom shape, no cracks in surrounding material, correct compression, too loose fails, in flight, too tight cracks the aluminum. Why it was difficult. 47 rivets in confined space, multiple angles, some nearly impossible to reach. Wing structure flexed during installation, constantly changing alignment. Each rivet had to be perfect. Overdriven meant cracked aluminum, underdriven meant loose rivet. Both meant structural failure, temperature mattered, aluminum expanded and contracted, affected rivet seating. Night shift actually had advantage cooler temperatures, more stable metal. Rose's theory. Install 6 primary rivets first. Stabilize wing structure. Then install 41 secondary rivets while wing was rigid. The risk. If she was wrong about which positions were primary, the wing would fail catastrophically during stress testing. At 11:47 p.m., Rose climbed into the wing cavity. Time to find out if intuition and experience could override engineering orthodoxy. 11:47 p.m., September 18th, 1942. Rose positioned herself inside the wing cavity, aluminum walls, close, her rivet gun ready, Helen outside with bucking bar, Frank standing by with inspection mirror and calipers, rivet point 1, forward main spar attachment, most critical position. This rivet carried primary wing bending loads. Rose pressed the gun against the hole, felt the alignment, steady pressure, trigger pull, sharp pneumatic crack. 3 seconds, rivet set. Helen felt the reverberation through her bucking bar, clean impact, good compression. Frank crawled partway into the wing with his inspection mirror, examined the rivet head, perfect mushroom formation, no cracks in surrounding aluminum, proper compression. Pass, Frank called out. Rose checked her watch. 11:50 p.m., 3 minutes for 1 rivet. Standard process took 15 minutes for the first rivet. She was already ahead. Rivet point 7, aft main spar attachment, awkward angle. Rose had to brace herself against the wing structure. Work by feel. Couldn't see the rivet head from her position. Gun positioned. Pressure. Applied. Trigger. Another clean crack. Rivet set perfectly. Frank inspected. Pass. 11:53 p.m., 6 minutes total, 2 rivets installed. Standard process, 30 minutes. Rose heard murmuring from the catwalk above, workers gathering to watch, word spreading through the plant, night shift coming to see if the impossible was possible. Rivet point 13. Upper wing root. Critical stress concentration point. This position carried torsional loads during flight. Wing twist forces concentrated here. Rose positioned carefully. This rivet had to be perfect. She breathed out slowly. Fired. Perfect set. Frank. Pass. 11:58 p.m. 3 primary rivets installed. 9 minutes total. The wing already felt different. More stable. Less flex when Rose moved inside the cavity. Rivet point 22. Mid-spar connection. Rose noticed immediately the wing wasn't moving like it usually did at this stage. The structure was rigid, the skeleton taking shape. She installed the rivet quickly. Clean, efficient. Frank, pass. 12:04 a.m., 4 rivets, 17 minutes. The wing structure noticeably stable now. Rose could feel it through her body pressed against the aluminum. No movement. No flex. Just solid metal. Rivet point 31. Lower wing root. Nearly impossible reach. Deepest point in the cavity. Rose had to wedge herself at an extreme angle, shoulder jammed against the structure, one arm extended fully, gun positioned more by touch than sight. She fired. Rivet set, but something felt wrong. Rose emerged from the cavity, inspected visually from outside while Frank checked from inside. The rivet mushroom head was slightly off-center. Not much, maybe 2 millimeters. But not perfect. Frank's inspection took longer. He measured carefully, used his calipers, checked compression. Finally, marginal, within tolerance but barely. Mitchell's voice from the catwalk. "You sure about that rivet?" Rose looked up at him. "It's within spec." We continue. "If that rivet fails during stress testing..." "It won't," Rose said. "It's within Boeing tolerance standards." Mitchell didn't look convinced, but he nodded. 12:11 a.m. 5 rivets installed. 1 marginal but acceptable. 24 minutes elapsed. Rivet .44. Final primary position. Aft lower spar. Darkest corner of the wing cavity. No light penetration. Rose working entirely by touch now. She positioned herself, called out to Helen. "Bucking bar positioned?" "Positioned," Helen confirmed. "On 3. 1, 2, 3. Rose fired. Perfect sound. Clean vibration through the gun. She knew immediately it was good. Frank crawled deep into the wing cavity. Used his flashlight and inspection mirror. The beam of light caught metal, created shadows. He examined the rivet from multiple angles. Long pause. 30 seconds. Rose waited. Helen waited. The crowd on the catwalk waited. Frank's voice from inside the cavity. Perfect rivet. Pass. 12:18 a.m. All 6 primary rivets installed. Total time, 31 minutes. Standard process 4, 6 rivets, 3 hours minimum. Rose emerged from the wing cavity, stretched, her shoulders ached, hands vibrating from the pneumatic gun, wiped sweat from her forehead despite the cool night air. "Helen, how's it feel?" Rose walked around the wing, ran her hand along the aluminum surface, pushed gently against the structure. Testing. No flex, no movement. The wing was solid. "It's locked," Rose said. "Wing won't move now." Frank pressed against the wing structure himself. Felt the rigidity. His expression changed. 15 years at Boeing, and he'd never felt a wing this stable with only 6 rivets installed. "This is different," Frank said carefully. "Structure's already rigid." Mitchell climbed down from the catwalk, approached the wing, inspected the 6 installed rivets personally, pushed against the wing structure, tested the stability. He looked at Rose. 31 minutes, 6 rivets, and the wing's already structural. "Now we fill in the secondary 41, Rose said. "Should take 90 minutes. Mitchell checked his watch. "It's 12:20 a.m. If you're done by 2 a.m., you've proven your point. We'll be done by 1:50, Rose said. Mitchell studied her face. Confidence, not arrogance. Just certainty born from 2,000 repetitions. "Then prove it," Mitchell said. Rose climbed back into the wing cavity. But this time, everything was different. 12:20 a.m. Rivet point 2. First secondary position, adjacent to primary rivet 1. Rose positioned her gun. Fired. Rivet set in 90 seconds. Standard time for this position, 4 minutes. Why faster? The wing was stable now. No flex, no constant alignment adjustment. Rose could work smoothly without fighting unstable structure. Frank's inspection, faster too. Less concern about structural integrity. The 6 primary rivets already guaranteed that. Frank just verified rivet quality. Pass. Rivet point 3. 80 seconds. Clean installation. Helen found her rhythm with the bucking bar. No hesitation. Adjustment needed. Just position, compress, done. Rose worked through points 4, 5, 6, average 75 seconds per rivet. 12:35 a.m. 10 total rivets installed. 16 secondary positions remaining to reach point 2-2. The crowd on the catwalk was growing. Word had spread beyond night shift, day shift workers staying late, engineers arriving from the engineering building. Skeptical but curious. Someone had brought coffee. The smell filled the assembly area. Rose could hear quiet conversations above. Couldn't make out words, didn't matter. She focused on metal and rivets. Rivet points 8 through 12. Rose hit her stride. Muscle memory, perfect rhythm. Gun pressure, position, fire, inspect, next. No wasted motion, no hesitation. Helen and Frank synchronized with her movements. 3-person team operating like one organism. 60 seconds per rivet now, 12:52 a.m. 20 rivets complete, 27 remaining. Mitchell stood on the catwalk with a notepad. Calculating. Current pace meant 1:45 a.m. completion. Total time, 110 minutes versus standard 1,440 minutes. 1,300% improvement. But improvement meant nothing if quality suffered. Mitchell watched Frank's inspections carefully. Every rivet passing, no marginal installations, no compromises. Rose briefly emerged from the wing cavity, drank water from her thermos, rolled her shoulders, flexed her hands. The pneumatic gun vibration was taking its toll. Constant hammer impacts traveling through her arms. Helen noticed. You need a break? Finish first, break later. Rose climbed back into the cavity. 27 rivets remaining, body aching but mind sharp. This was the final push. Rivet points 21 through 30. Rose pushed the pace. 55 seconds per rivet. Faster than before. Frank called out, "Slow down. I need to verify properly." Rose paused. Let him catch up. Mitchell's voice from above. "Speed doesn't matter if rivets fail inspection." Rose understood. Maintained 60-second pace. Fast but controlled. Quality over speed. 1:18 a.m. 35 rivets complete. 12 remaining. Rose's hands were cramping. Pneumatic gun vibration for over 90 minutes. Constant pressure. Constant trigger pulls. Each impact sending shock through tired muscles. But the wing structure was perfect. Every rivet passing inspection. The method was working exactly as Rose knew it would. The skeleton she'd created with the first 6 rivets distributed loads properly. Secondary rivets installed easily. No fighting the structure. No constant adjustment. Just clean, efficient work. 12 rivets remaining. 30 minutes to 1:50 a.m. deadline. Rose had time. She continued. 1:18 a.m. 12 rivets remaining. Rose's hands were cramping badly now. 90 minutes of pneumatic gun vibration. The tool weighed 12 pounds. Constant pressure against aluminum. Constant trigger pulls sending shock waves through forearms and shoulders. She flexed her fingers between rivets. Tried to shake out the pain, didn't help much. Rivet points 32 through 37. Rose fought through the fatigue. Each trigger pull harder than the last, muscles protesting. But her technique stayed precise. Pain didn't matter, only quality mattered. 65 seconds per rivet. Slightly slower. Frank noticed but said nothing. Inspections still passing. 1:32 a.m. 41 rivets complete. 6 remaining. Helen called into the wing cavity. "Rose, your hands okay?" "Fine." Rose lied. Her hands were not fine. Cramping, aching. But 6 rivets left. Maybe 8 minutes of work. She could push through 8 minutes. Rivet points 38 through 42. Rose's technique stayed solid despite the pain. 2,000 wing installations had built muscle memory that overrode fatigue. Her body knew what to do even when exhausted. 70 seconds per rivet now. Fatigue slowing her down, but still faster than standard process. 1:42 a.m. 46 rivets complete. 1 remaining. Rose paused, breathed. Her hands were shaking slightly. Not from nerves. From muscle fatigue. She gripped the rivet gun tighter, steadied herself. .45. Upper aft position. Easiest access point in the entire wing. Rose had saved it for last intentionally. Knew she'd be tired by the end. Wanted the final rivet to be straightforward. She positioned the gun. Helen positioned her bucking bar. Frank stood watching. Inspection gauge ready. The catwalk was silent now. 50 people watching, waiting. Mitchell had his stopwatch ready. 1:43 a.m. showing on his watch. Rose pressed the gun against the final rivet hole. Steady pressure despite cramping hands. She'd installed 2,046 rivets using this exact motion. One more wouldn't kill her. Trigger pull. Sharp pneumatic crack. Clean sound. Perfect compression. Rivet set. Frank inspected immediately. Used his mirror. Checked the mushroom head formation. No cracks. Proper compression. 1:48 a.m. Rose emerged from the wing cavity slowly, every muscle protesting. She stood, looked at the completed wing, 47 rivets, all installed, all verified. Total time, 2 hours, 1 minute. Standard time, 24 hours. Helen set down her bucking bar. We did it. Frank said nothing, just stared at his inspection clipboard. 47 entries, 47 pass marks. One marginal but within tolerance. The catwalk remained silent. Then one worker started clapping, another joined. Within seconds, applause from 50 people. But Rose didn't smile, didn't celebrate, just looked at Mitchell. Now we need stress testing, Rose said. September 19th, 1942, 6:30 a.m. Boeing Test Facility, Building 9. Rose hadn't slept. Stayed at the plant through the night. Watched them move her wing to the test facility at 4 a.m. Forklifts carrying it carefully. Her work, her risk. Everything riding on whether that wing could survive 6 Gs of force. The test facility was a massive concrete building, high ceiling, steel test frames, hydraulic systems. The smell of oil and metal and tension. Test engineer, Martin Webb, 43 years old, 15 years testing aircraft structures. His reputation was simple, methodical, unforgiving, precise. Webb rejected 8% of all wings that came through his facility. He found failures that others missed. Rose watched him examine her wing before testing. He measured rivet heads, checked spacing, verified installation quality. His face showed nothing. Professional, detached. The test setup was brutal in its simplicity. Wing mounted in a steel frame. Hydraulic rams attached at key stress points where flight loads would apply during actual flight. Strain gauges glued to the aluminum skin. Sensors that would detect any structural deformation, any crack formation, any rivet failure. Test sequence was standardized. 1 G load first equivalent to level flight, then 3 G hard turn, then 4.5 G emergency maneuver. Finally, 6 G maximum test specification. Each load held for 2 minutes, while Webb examined the structure. Combat loads rarely exceeded 4 Gs, but Boeing tested to 6 G to provide safety margin. The wing had to survive forces 50% higher than expected combat loads. Rose stood behind safety glass, Helen beside her, Frank on her other side. All three exhausted. All three silent. Mitchell was there with 3 Boeing engineers. Corporate had sent observers. This test mattered beyond one wing. If Rose's method worked, it changed everything. If it failed, nothing changed, and Rose went home unemployed. Webb started the test sequence. No ceremony, no announcement. Just professional execution. Applying 1 G load. Hydraulic rams engaged. Slow pressure increase. Wing flexed slightly. Natural response. Aluminum bending under load. Strain gauges showed readings within normal parameters. Webb walked around the wing, examined it from multiple angles. Flashlight beam catching metal surfaces, looking for anything wrong. Any rivet head deformation, any crack formation, any sign of weakness. 2 minutes. 1 G stable, Webb announced. No anomalies detected. Rose exhaled slightly. First test passed. 3 more to go. Applying 3 G load. Rams increased pressure. Wing deflected more noticeably. 3 times the force of level flight. This was where poorly installed rivets sometimes started showing problems. Small movements, slight loosening, early warning signs. Webb watched his strain gauges, walked around the wing again. More careful examination now. Higher loads meant higher risk. 30 seconds, 60 seconds, 90 seconds. Rose watched rivet point 31, the marginal one from last night. Slightly off-center mushroom head, within tolerance but barely. If any rivet failed first, it would be that one. No movement, no deformation, holding solid. 2 minutes. 3G stable, Webb said. No anomalies detected. Helen grabbed Rose's hand. Squeezed. Rose didn't respond. Eyes locked on the wing. 2 more tests. 2 more chances for failure. Applying 4.5 G load. This was the critical test. 4.5 Gs exceeded most combat loads. This was where weak wings failed. Where poor riveting showed itself. Where structural problems became catastrophic. Webb increased hydraulic pressure slowly. Wing deflected significantly. Aluminum skin visibly stressed. This was brutal force. Metal bending. Structure fighting against loads it was designed to survive but barely. Strain gauges showed readings climbing. Still within parameters. But approaching limits. Rose watched the 6 primary rivet positions. Everything depended on those 6. If her theory was wrong, if those weren't actually the primary load-bearing positions, the wing would fail right now. 10 seconds. 20 seconds. 30 seconds. Webb walked completely around the wing, flashlight beam examining every surface, looking for the telltale signs: rivet head distortion, aluminum cracking, skin buckling. 60 seconds. 90 seconds. Rose noticed slight discoloration around rivet point 31. Stress. Concentration. Metal responding to load. Not a failure. Just visible stress. But it made her stomach clench. She said nothing. Watched. Waited. 120 seconds. 4.5 G stable, Webb announced. No structural failure detected. One Boeing engineer exhaled audibly. Mitchell remained silent. Expression unreadable. 1 test remaining. 6G. Maximum specification. This was the make or break test. Webb looked at Mitchell. Ready for 6G? Mitchell nodded. Proceed. Webb's hand moved to the hydraulic controls. Applying 6G load. This is maximum test specification. Webb increased hydraulic pressure to maximum. The rams engaged with audible force. Mechanical grinding. Metal under extreme stress. The wing deflected dramatically. Aluminum skin bending. Visible deformation along the span. This was 6 times the force of gravity. 6 times the wing's own weight pressing down. This was the kind of load that revealed every weakness, every mistake, every compromise. Rivet. Rose watched the structure bend. Watched metal flex beyond anything she'd seen during installation. This was the moment. If her 6-rivet skeleton theory was wrong, the wing would fail catastrophically right now. Primary rivets would shear. Secondary rivets would cascade fail. The wing would buckle. 10 seconds. Strain gauges showed readings at the edge of acceptable parameters, not over limits. But close, very close. Webb walked around the wing slowly. His flashlight beam examined every surface, every rivet head, every aluminum panel, looking for crack initiation, looking for rivet head deformation, looking for skin buckling between rivet rows. 20 seconds. Rose's eyes locked on the 6 primary rivet positions. Positions 1, 7, 13, 22, 31, 44. Everything depended on these. If they held, the wing held. If they failed, everything failed. Position 31 showed that same discoloration, stress concentration visible, but no movement, no deformation, just metal under load doing exactly what it was designed to do. 30 seconds. Helen's hand gripped Rose's tighter. Frank stood rigid. Mitchell chain-smoked behind them. Boeing engineers watched in silence. 40 seconds. Webb stopped at position 1. Forward main spar attachment. Most critical rivet in the entire structure. His flashlight beam examined it closely, looking for any sign of movement, any microscopic crack formation, any indication of impending failure. Nothing. 50 seconds. Webb moved to position 44, aft lower spar. The perfect rivet Rose had installed last among the primary 6. Webb examined it from 3 different angles, used his inspection mirror, checked surrounding aluminum. Still nothing wrong. 60 seconds. 1 minute at 6 Gs. Rose knew the protocol. Webb would hold maximum load for 2 full minutes. Standard Boeing test specification, 120 seconds of maximum stress. If the wing survived 2 minutes at 6 Gs, it would survive anything combat could throw at it. 70 seconds. Webb examined the secondary rivet field now. The 41 rivets Rose had installed after the primary skeleton. These rivets didn't carry primary loads, but they prevented buckling, distributed stress, kept aluminum skin stable under deflection, all holding, no failures, no movement. 80 seconds. A faint creaking sound came from the wing structure. Aluminum settling under sustained load. Normal sound. Expected. But it made Rose's heart race anyway. Webb didn't react. He'd heard that sound thousands of times. Aluminum talking. Not failing. Just responding to force. 90 seconds. Helen whispered, "It's holding." Rose didn't respond. 30 seconds remaining. Longest 30 seconds of her life. 100 seconds. Webb completed his examination circuit, returned to his strain gauge monitoring station, checked readings, verified all sensors functioning properly, confirmed load still at 6 Gs. 110 seconds. Rose watched position 31, the marginal rivet. Still, holding. Discoloration visible but no structural failure, within tolerance meant exactly that. Acceptable under load. 115 seconds. Webb's hand moved toward the hydraulic control, ready to release pressure at 120 seconds exactly. Professional? Precise. No early release. No shortcuts. 118 seconds. 119 seconds. 120 seconds. 2 minutes at 6 G, Webb announced, beginning pressure release. He decreased hydraulic pressure slowly. Controlled release. The wing returned to neutral position gradually, metal relaxing, structure unloading, the wing settled, silent, intact. Webb began final inspection. This took 45 minutes. He examined every rivet head with magnification, looked for microscopic cracks, checked for rivet head distortion, measured aluminum skin for permanent deformation, analyzed strain gauge data for stress concentration patterns. Rose, Helen, and Frank waited. No talking. Just waiting. Mitchell smoked 4 cigarettes. Boeing engineers discussed quietly among themselves, pointed at the wing, gestured at monitoring equipment. Rose couldn't hear their words, didn't want to. 7:15 a.m. Webb emerged from the test chamber. Clipboard in hand, expression professional, neutral, unreadable. He approached Mitchell. The group fell silent. Webb read from his test report, all 47 rivets intact, no shearing detected, no structural cracks observed, no buckling detected. Strain gauge readings within acceptable parameters throughout all test phases. Wing deflection consistent with Boeing engineering specifications for B-17 Flying Fortress wing root structure. He paused, then delivered his conclusion. This wing passes Boeing stress test protocol. Rose felt her knees weaken. Helen grabbed her arm. Frank exhaled for the first time in 2 minutes. But Webb wasn't finished. However, Webb continued, I note unusual installation sequence per the work order documentation, submitted with this wing. Mitchell's expression didn't change. Unusual but effective. Effective doesn't mean certifiable, Webb said. This wing is structurally sound. I'm signing off on the structure itself. But Boeing cannot implement this installation method fleet-wide without right field certification of the modified procedure. Rose felt her stomach drop. The wing passed, proved the method worked. But bureaucracy blocked implementation. How long for right field certification? Mitchell asked. Standard process, 6 to 8 months minimum, Webb said. Rose spoke up. We don't have 6 months, we need 350 bombers per month now. Today, not next spring. Webb looked at her directly. I don't make policy, miss, I test wings. This wing passed. But the installation process isn't certified through official channels. Standoff. Then one of the Boeing engineers stepped forward. Thomas Keller, Chief Structural Engineer, 51 years old. Had been silent throughout, the entire test. Webb's right about certification, Keller said. But there's an alternative path. Everyone turned. Mitchell, Webb, Rose, the other Boeing engineers, all waiting. Keller explained, we classify this as a field modification rather than a design change. Field modifications can be implemented with plant manager approval and chief engineer sign-off. They don't require right field certification, just internal Boeing Review Board approval. Mitchell's eyes narrowed. How long for internal review? 2 weeks if I expedite it, maybe 3. Versus 6 months for right field? Correct. Webb interjected. Field modifications are typically minor changes. Cable routing, fastener substitutions. This isn't minor, this changes fundamental assembly sequence. The technical definition of field modification is any process change that doesn't alter engineering specifications, Keller said. The wing design hasn't changed. Rivet specifications haven't changed. Structural requirements haven't changed. Only the installation sequence changed. That fits the technical definition. Webb didn't look convinced, but didn't argue. His job was testing wings, not interpreting policy. Mitchell asked the critical question, will you sign off as chief engineer? Keller walked to the wing, examined it personally, looked at the 6 primary rivet positions, pulled out structural drawings from his briefcase, spread them on a nearby work table, compared the drawings to the actual installed rivets. After 10 minutes of examination, Keller looked up. These 6 positions, 1, 7, 13, 22, 31, 44, these are the primary load paths according to our stress analysis calculations, Rose said quietly. I know. How did you identify them? I watched 2,000 wings flex during installation, saw where stress concentrated, where the structure stabilized, where loads transferred. Keller studied her face. Our engineering team spent 6 weeks doing finite element analysis to identify those exact positions. You found them through observation. Math and metal say the same thing, Rose said, just different languages. Keller turned to Mitchell. I'll sign off. This is sound engineering, just discovered through empirical observation rather than analytical calculation. The end result is identical. We're installing rivets in optimal load path sequence. Mitchell asked, how fast can we implement? I'll prepare documentation today. Present to review board Monday morning. If approved, we can begin training program Wednesday. Full implementation across all stations by end of September. Rose finally allowed herself to breathe. 2 hours and 1 minute. Now certified. Now real. September 21st, 1942. Monday morning, Keller presented the Kowalski primary rivet method to Boeing's internal review board. 7 senior engineers, 3 production managers, 2 corporate executives. All crammed into a conference room reviewing Rose's hand-drawn diagrams and Webb's test data. The meeting lasted 3 hours. Arguments about precedent, concerns about liability, questions about why field mechanics were dictating engineering procedures. Keller's response was simple. Because the field mechanic was right and we were slow. Review board approved implementation 8-2. Dissenting votes cited insufficient long-term testing. Majority cited production emergency and successful stress test results. Boeing Corporate gave authorization that afternoon. Begin training immediately. September 23, 1942. Training program started. Rose assigned as primary instructor, 10 wing assembly stations, 8 workers per station, 80 people to train in the new method. Rose stood in front of the first training group. 20 riveters, buckers, and inspectors. Some eager, most skeptical, all exhausted from standard production schedule. She explained the method. 6 primary positions. Structural skeleton. Secondary fill-in. Expected time. 2 to 3 hours versus 24. Questions came immediately. We've been doing it the old way for 2 years. Why change now? Rose. Because the old way takes 24 hours, and we need to build 350 bombers per month. This violates everything we learned in training. Rose. Training taught you to follow procedures. I'm teaching you to understand why procedures exist. What if it fails in combat? Our names are on those wings. Rose. I've installed 2,000 wings the old way. This way is better. I'll stake my job on it. One veteran riveter stood up. Bill Crawford. 46 years old. 20 years at Boeing. Started when aircraft were still fabric-covered wood frames. He'd seen plenty of improvements that failed. Crawford confronted Rose directly. You think 8 years in Detroit makes you smarter than Boeing engineers? No, Rose said. I think 2,000 wing installations gave me data the engineers didn't have. They calculated stress on paper. I watched it happen in metal. Both valid. Different perspectives. Perspectives, Crawford's voice rose. This isn't philosophy. This is 10 men's lives depending on whether your perspective was right. You're correct, Rose said. 10 lives per wing. We built a wing using this method. It passed stress testing at 6 Gs. That wing is certified. This method works. Crawford shook his head. 1 wing, 1 test. You want to bet the entire production line on 1 test? I want to bet the production line on ending the bottleneck that's killing pilots who are waiting for aircraft we're not building fast enough. Silence. Crawford stared at her. Then walked out of the training session. Mitchell intervened within an hour. Found Crawford in the break room. Learn the new method or transfer to a different station. Crawford returned to training. Grudging, hostile. But he learned it. September 25th, 1942. First production wing using the Kowalski method at a station other than Rose's, Station 4. Experienced team. Certified on the new process. Completion time, 2 hours, 18 minutes. Wing passed stress testing. All rivets verified. Structural integrity confirmed. September 26th. 3 more stations trained and certified. Wings completed in 2 to 22, 2:15, and 2:31. All passed stress testing. The method was replicating. Rose's technique spreading from 1 station to 10. September 28th. 6 stations fully operational using the new method. Average completion time, 2 hours, 20 minutes, compared to previous 24 hours. Quality control was critical. Every wing still went through web stress testing. Boeing couldn't afford failures, couldn't risk wings failing in combat because of rushed implementation. All wings passed, but problems emerged. Not structural problems, human problems. Some riveters couldn't consistently identify the 6 primary positions. The positions weren't marked on the wings. Workers had to know them from memory or reference diagrams. Easy to confuse position 13 with position 14. Easy to install a secondary rivet thinking it was primary. Station 6 produced a wing that failed initial inspection. Wrong rivets installed as primary. Worker had confused position 22 with position 23. Frank Chen caught it during inspection. Wing was rejected. Had to be completely disassembled and reinstalled. Rose created a solution that night. Simple. Obvious in hindsight. She took red paint. Marked the 6 primary positions on wings during prep phase. Small red dots, clearly visible, impossible to confuse. She presented the modification to Keller the next morning. Why didn't we think of that? Keller said. Because engineers think about calculations, Rose said. Workers think about not making mistakes at 2 a.m. after 10 hours on shift. The red dot system was implemented immediately. All wings marked during prep. Primary positions clearly identified. Confusion errors dropped to 0. September 30th, 1942. All 10 wing assembly stations certified on the Kowalski method. Full implementation across Boeing Plant 2. Mitchell reviewed production numbers. Math was simple and dramatic. Previous capacity, 140 B-17 seconds per month. Current projected capacity, 320 B-17 seconds per month. Not quite the 350 target, but 229% improvement in 30 days. Army Air Forces noticed immediately. October 15th, 1942. Boeing Corporate sent technical documentation to Douglas Aircraft in Long Beach, California, and Lockheed Vega in Burbank. Both plants produced B-17 seconds under license from Boeing. Both plants faced the same 24-hour wing route bottleneck. Douglas implemented the Kowalski method within 1 week. Their chief engineer reviewed the stress test data, examined the installation sequence, approved it immediately. Results at Douglas. Production increased from 95 B-17 seconds per month to 280 per month by November. Lockheed Vega was more cautious. Corporate culture favored extensive testing before implementation. They ran the method on a limited basis first. 10 wings. All passed stress testing. Full implementation. Approved in December. Results at Lockheed Vega. Production increased from 140 to 240 B-17 seconds per month. Previous combined total, 375 per month. The bottleneck was broken. Not just at one plant. Across the entire B-17 production network, Army Air Forces logistics officers revised their bomber replacement projections, revised mission planning, revised strategic bombing campaign timelines. November 1942. 8th Air Force losses over Germany averaged 40 bombers per mission. Brutal casualty rate. But replacement rate now exceeded losses. Bomber strength maintained, eventually increased. Strategic bombing campaign continued without pause. Germany's industrial capacity under sustained attack. Oil refineries, ball-bearing factories, aircraft plants. All targeted because America could replace losses faster than Germany could inflict them. December 1942. The method spread beyond B-17 production. Consolidated Aircraft in San Diego produced B-24 Liberators. Different aircraft. But similar wing route, geometry. Similar 47 rivet bottleneck. Consolidated's chief engineer contacted Keller, requested documentation on the Kowalski method, adapted it for B-24 wing structure. B-24 production at Consolidated increased from 200 per month to 450 per month. The ripple extended further. P-38 Lightning production faced similar wing assembly issues. Lockheed applied modified version of the method. Production increased 180%. C-47 transport production. Same principle applied. Different aircraft but same fundamental problem: sequential rivet installation on primary structures. By January 1943, the Kowalski method was standard procedure across U.S. military aircraft production, bombers, fighters, transports, any aircraft with riveted wing structures. Total impact, U.S. bomber production increased 224% in 4 months, September to January. One method. One field mechanics observation, industry-wide transformation. But Rose never saw most of this impact. She was still working night shift at station, the 7th of February 1943. Rose Kowalski still worked as a riveter at Wing Assembly Station 7. Night shift, same hours, same coveralls, same aluminum shavings under her fingernails. Wage: $0.95 per hour. Same rate as September. No raise for the innovation that transformed aircraft production. Boeing's wage structure didn't have a category for field mechanic who solved the production bottleneck. December 1942. Mitchell had offered Rose a supervisor position. Salary increase. Day shift. Desk in the production office. Authority over 20 workers. Rose declined. I'm a riveter, not a manager. She preferred working with metal to working with paperwork. Preferred the rhythm of the rivet gun to the rhythm of staff meetings. The wing cavity made sense to her. The office didn't. Mitchell tried again in January. You have leadership ability. You could train more workers, implement more improvements. I train workers every week, Rose said. Don't need a desk to do that. She stayed at Station 7, installed wings, trained new workers during breaks, watched the production numbers climb. That was enough. February 10th, 1943. Army Air Force's delegation visited Boeing Plant 2, led by Major General Ira Eaker, commanding general of the 8th Air Force. The man responsible for daylight precision bombing campaign over Germany. Eaker wanted to meet the person who solved the production bottleneck. Mitchell arranged the meeting. Rose met Eaker in the assembly area. She wore coveralls, fresh from night shift, grease on her hands, coffee stains on her collar. Eaker was in full uniform. Dress greens, campaign ribbons, command pilot wings, stars on his shoulders. He looked at Rose, 5'4", 118 pounds, exhausted from 10-hour shift, and saw the person who'd kept his bomber groups operational. Miss Kowalski, Eaker said, your method is keeping my bomber groups at operational strength. Just doing my job, sir. Your job saved the strategic bombing campaign. We're flying missions today that would have been impossible 4 months ago. Missions that are destroying Germany's ability to make war. Rose looked at him directly. Did it help the pilots? Eaker understood the question. She didn't care about strategy or campaigns. She cared about whether pilots were dying waiting for aircraft. Yes, Eaker said. It helped the pilots. We're replacing losses faster than we're taking them. Bomber crews have aircraft. That's because of you. That mattered to Rose. More than any praise, more than any recognition, pilots had aircraft. That was the point. Eaker presented her with the Army Air Force's Commendation for Civilian Service, certificate, medal, official recognition from the United States military. Rose accepted it, thanked him, went back to work. March 1943. Life magazine ran a feature story on women in war production. The women who build the arsenal of democracy. 12 pages, photographs of women working in aircraft plants, shipyards, munitions factories. Rose was featured in a 2-page spread. Photograph of her inside a wing cavity. Rivet gun in hand. Concentration on her face. Caption read, Rose Kowalski, the riveter who changed aircraft production. The article explained the Kowalski method, described the bottleneck, described her solution, described the impact 224% increase in bomber production. Rose hated the publicity. I'm not special. Thousands of women doing this work every day. They deserve the recognition, not me. But the story inspired women across the country. Showed that innovation could come from the factory floor. Showed that practical experience mattered as much as engineering degrees. Showed that a riveter from Detroit could change the war. Letters arrived at Boeing Plant 2, addressed to Rose, women from other factories, women working in war production, thanking her, telling her she inspired them to speak up about improvements they'd observed. Rose read some of the letters, felt uncomfortable with the attention, put them in a drawer, went back to work. April 1943. Boeing offered Rose a position in the engineering department. Junior engineer, formal training provided. Salary increase to $1.75 per hour. Opportunity to work on future aircraft designs. Rose declined again. Keller tried to convince her personally. You have engineering instinct, natural understanding of structural mechanics. We need that perspective in the design phase. Then hire more people who've worked on the floor, Rose said. I work better with my hands than with slide rules. You could do both. I'd rather do one thing well than 2 things poorly. She stayed at Station 7. Mitchell stopped offering promotions, understood that Rose wanted what she wanted, not what the company thought she should want. Rose continued working through 1943, 1,944 into 1,945. Estimated total 8,000 plus wing routes installed using her method. Trained over 200 workers personally. Identified 3 more assembly improvements, minor modifications that saved minutes rather than hours, but minutes mattered when building hundreds of aircraft per month. She never kept count of the wings she built, never calculated her contribution. When other workers asked, "How many wings have you done?" she'd shrug. Enough. August 17th, 1943. Schweinfurt-Regensburg mission. 8th Air Force launched the deepest daylight penetration raid into Germany to date. Target: ball-bearing factories. These factories produced bearings for German tanks, aircraft, and submarines. Destroy them. Cripple German war production. 376 B-17 flying fortresses participated. Largest bombing mission in history to that point. German response was catastrophic. Luftwaffe threw everything available at the formation. Bf 109 seconds. W 190 seconds. Even Bf 110 heavy fighters with rockets. Results: 60 B-17 seconds shot down, 27 damaged beyond repair. 87 bombers lost, 23% loss rate, but 289 aircraft returned to England. Many with catastrophic damage, wings shot full of holes, structures compromised, hydraulics destroyed, engines failed, yet they flew home. Critical question emerged during post-mission damage assessment. Would wings assembled using the Kowalski method hold up under combat damage? Engineers examined the returning aircraft, documented every hit, every structural failure, every system compromise.